This is Ham Donishman back again for another video series for Verisys system and also smart equipment. Today I want to talk about a topic that is fairly new within our HVAC industry, and this particular topic is called Fault Detection Diagnostics, FDD. We released our fault detection diagnostic technology within our rooftop back in 2014. And we have been collecting information, collecting data from job sites, and seeing the difference that it makes when you do have fault detection diagnostics within your rooftop. It creates an experience for the mechanical contractor or the service provider that FDD can provide you with combination of smart equipment and combination of Verisys to be able to give you information ahead of time when you have a true problem from a refrigeration perspective of the system. Our FDD, there's two different types of FDD within our rooftop. One area it has to do with the economizer, and that's one side of the FDD. But the main side of the FDD that I want to talk about today has to do with our refrigeration circuits. I want to point out the hardware. I want to point out the inputs that we have, where we have to have a factory installed and from an inputs perspective on the refrigeration circuit. And we also have a retrofit kit that you can purchase from Johnson Controls, and this retrofit kit can be installed in the field for our own type of equipment, which would be Johnson Controls rooftop or a York rooftop or a Coleman rooftop, or any of them that have basically the smart equipment simplicity controller on that particular rooftop. It must be a simplicity smart equipment controller to be able to use that retrofit kit. So just a quick little history about FDD. FDD is a technology that's been around for a very long time, and it's been mainly used in the industrial side of the systems that are out there. And again, from an HVAC perspective, it's fairly new. But we have created an embedded solution within our rooftop, and we're going to continue this embedded solution throughout other parts of the equipment line cards that we have. One key thing I want to identify here, and it's important, and I'm not crossing any type of boundaries here, is that our technology is FDD has been proven well over 25 years. The reason I say that is because we have partnered with another company called FDSI, Field Diagnostics Service Incorporated, and many research years have gone through the algorithms that they have written, and we basically took and partnered with that company and utilized their algorithms within our system to create this experience for our customers. So it's important to me, and it's important for the audience of watching this video, that this particular algorithm that we're using and it's embedded on our equipment, it's not something that Johnson Controls is providing, but it's something that's been well proven in the industry for well over 20 years. So let's quickly look at the hardware itself. The hardware itself, obviously I started with the smart equipment controller, and that's part of our rooftop main controller platform. So you have to have that controller before you could have the FDD option. The FDD controller is this controller, it's right here that you see. It connects into the main controller through our, what we call our sensor actuator bus, our SA bus. And it communicates basically a backnet communication within the equipment itself. You have one controller for every two circuits of this system. And so let's say if I have a 4-circuit rooftop with 4 compressors, then I would have to have two of these FDD boards, and they will be communicating on the same bus. So within this example right here, I have one. And the important thing to know about this, and from a factory perspective, you will have all this factory mounted, or you would have to do this in a field retrofit. But every circuit is going to have 4 sensor inputs. You will have 2 pressure inputs and 2 temperature inputs. So your pressure around liquid pressure, suction pressure, or your temperature around liquid and then suction temperature, you will have those inputs coming directly into this board. Those are mandatory inputs for the algorithm to be run within the controller. The FDD, being part of the refrigeration, obviously only runs during the warm time of the season. Now, if you live in the southern part of the country or western part of the country and there's always warm weather there, most likely your FDD is running all the time. If the temperature dips below certain temperature range, most likely around 55 degrees, then the cooling is not going to be activated, then your FDD is really not running. So again, those inputs are being collected within this controller. They're communicating back and forth between the main controller and the FDD controller, and they're continuously monitoring the refrigeration side of the system by those pressure inputs and then by those temperature inputs. So some of the examples of FDD that we can create are simple things like recover charge, or if you have to add charge, if you have any kind of heat transfer issues. These are the faults that can come into not only the smart equipment controller that you see here, but also throughout our Verisys system. So if the Verisys system is connected to our smart equipment rooftop that has been put together with FDD, all those faults are being generated and being created and sent to that dedicated person or tenant or mechanical contractor, and we can email and text you based on what that fault is. So just think about the value proposition here. If I'm a mechanical contractor and I know before the customer that I have to recover charge or have low charge, I know exactly which circuit it is. Before I even come to the job site, I know exactly what I have to bring to the job and where I have to look at it. I don't have to take out my instruments. I don't have to take out my gauges. I don't have to really climb on the roof to spend an hour or two just to figure out what the problem is. The system is going to be able to tell me that. We could also give you online calculation of superheat, subcooling, the efficiency, capacity. All that information is being calculated and is provided real time on the palm of your hand through your phone or your computer or your smart pad. So the other thing I want to show today, before I finish this video, I wanted to at least show you what it looks like on our system when it's connected to Verisys. I'm going to bring online a job site that I'm connected remotely. I'm currently, right now, I'm videotaping this in Milwaukee, Wisconsin, and I'm going to connect to a job remotely through my laptop here. I could do it through my phone, but it's easier to show you on my laptop. That I'm going to connect to a job site in Louisville, Kentucky that actually has FDD on a York 15-ton unit. So I want to bring that system up real quick. What you can see right now, this is a typical Verisys view. I have multiple different rooftops connected. These are all single zone rooftops. And I have York rooftops and also have combination of Trane rooftops that are connected within this system. This is a historical building we've been monitoring for a good 2 years now. And we've been very successful at providing the information that they need when they have problems. I'm going to go into this York East unit. This York East unit right now is operating, and a circle will come up and tells us it is cooling, it's occupied, it has one cooling stage. We got an outside air temperature around 84, we're supplying 55, and we got a return of 71 degrees. So this particular rooftop is definitely running FDD at this point. So I'm going to look at some previous alarms that were generated and was already text and or emailed to the service provider of this particular job, and at the same time I got them myself. So these are just examples of different faults, and these are really what we call service faults. They're not critical faults that would cause any kind of shutdown on the rooftop. All FDD faults that we generate, they're service faults. They're basically for monitoring more information, and then you would have to do something about it before you take advantage of FDD. If you don't do anything about it, obviously the system is going to operate the way it is. So here's an example of an FDD right now, and this one in particular is telling me circuit 1, we need to add charge. So really what that means is it needs to be charged because obviously the algorithm's telling us that, and I fully trust this algorithm because it's been around for a very long time and I have a lot of confidence behind it. But what you're really seeing here is that if the unit needs to add charge, that really what it means, the unit is not running very efficient. And what that means to the end customer, they are using more energy than they need to. So really the outcome of the FDD is not only you're providing a service to your customer, but you're also providing a really energy saving piece that goes along with the particular rooftop. So to me, this is a very big differentiator in the market. I'm going to quickly show you the trend, and I will conclude this video. Within the trend, we have pre-set up of all the objects or points of all the FDD objects. So depending on how many stages of cooling you have, in this case I have 2 stages. I have my suction pressure, suction temperature, liquid temperature, superheat, subcooling. So if I want to pull up this, my suction pressure, it's going to graph that out for me. So if I want to see what's going on a particular time and see how low my suction pressure has gotten, I could zoom in those sections. I could do the same thing with the liquid pressure to give me more information. So the area where I was having add charge, as a professional mechanical contractor, I should be able to really home into these data points and be able to tell exactly what's happening. And then this is the very nice thing from mechanical contractor. We are pre-calculating all the superheat information that they need to troubleshoot the system or the subcooling information they need for this particular system before they add charge. So this is the end of my video. I hope you enjoyed it, and I hope you could take advantage of FDD. Thanks for joining.